Okay, so here we have problem number 6. If the first order maximum for monochromatic light falling on double slit is at angle of 10 degree, what is the angle of the first minimum? Okay, so let's write down. So the first order maximum, which means m first order maximum is equal to 1. First order maximum, first, okay. It's falling at an angle of 10 degrees. So let me call it theta 1, which is 10 degree. So this m first order maximum is also 1, okay. What is the angle of the first minimum? So we have to find theta 2 when is the first minimum. What is the minimum one? The minimum is always starts 0, okay. First order minimum. Okay. First order minimum. So let's find out. So when there's a first order maximum, we have to use the formula for the constructive interference, and for the minimum we have to use destructive interference. For constructive interference we have formula where d sine theta is equal m lambda. For the destructive interference we have d sine theta m plus 1/2 divide times lambda, okay. So then we can just divide it as we did for the previous problem. So d sine 10 degree is equal m max first order maximum will be 1 multiplied to the lambda divided by d sine theta 2 sorry, actually it should be equal so is equal here we have to find 0 plus we have to substitute 0 plus 1/2 lambda, okay. So this d will cancel, lambda will cancel, then we end up with sine 10 degree is equal to the 1. Here we have sine theta 2 equal to the 1/2. Okay, so that means we end up with sine theta 2 is equal 0.5 multiplied sine 10 degree divided by 1, okay, and your theta is equal inverse sine 0.5 times sine 10 degree divided by 1. So that's it. I would like to explain further what does mean first order minimum and what does mean first order maximum. So basically when you have a slit, a double slit experiment, here you have a screen, okay. The first will appear the maximum one, and then it's like this one, okay. So obviously here you have destructive interference when it says that m is equal to 0 when first minimum, okay. And here you have also destructive, which is when m is equal to 1, here will be second minimum. Here you will have m is equal to 2, which is third minimum, okay. But what about this one? So let me just change the color. So then what about this one? So this will be your m is equal to 1 when first order maximum. So first order maximum. And here you have m is equal to 2, which is second order maximum, okay. And here you have m is equal to 3, which is third order maximum. Okay, just to be clear. So okay, then what else? So I think that's it.